Hello children, welcome to your chemistry online class. Last class we have studied about group 13 elements which is known as boron family. Today we are going to study about the group 14 elements carbon family. Carbon family is very important to us our daily life. What are the elements in the carbon family? It consists of the element carbon, silicon, then germanium, tin and lead. These are the elements in the carbon family. Carbon, silicon, germanium, tin and lead. And we know carbon is the basis of an entire branch of chemistry. What is that branch? Organic chemistry. And we know they are very important to our daily life and life of computers. Silicon and germanium are important semiconductors. We'll see deeply about carbon family. So it is group 14 elements. They have 4 valence electrons. Valence is plus 4 and its oxidation state is plus 4. It also show the oxidation state of plus 2. This family includes a non-metal which is carbon, metalloids that is silicon and germanium, then metal, zinc and tin are metals. We know the element carbon is called the basis of life. Occurrence. The carbon family occurs in different states. As we said earlier, carbon is a non-metal. Germanium and silicon are metalloids, semiconductors. Tin and lead are metals. Their general outer electronic configuration is Ns2 Np2. And in this, carbon and silicon forms 4 bonds with other elements. For example, carbon can form 4 bonds. Similar to that, silicon also can form 4 bonds with other elements. This is the electronic configuration of the carbon family. If you check here, you can see the last electron enters to the p subshell and 2 electrons are there in the valence shell. So hence its general configuration is Ns2 Np2. This is the trend in, we'll see the physical properties. If you check the physical properties, the ionization energy, you can see the ionization energy. They have higher first ionization energy. There's a very small decrease in ionization energy from silicon to germanium to tin. From tin to lead, there is a slight increase. These anomalies are due to the poor shielding effect of the inner core of d and f orbitals. We know the poor shielding effect. And we'll see the atomic radius. We know this carbon family form only covalent bond. So hence we will identify the size in the basis of covalent radius. There is a considerable increase in the covalent radius. Why? We know while moving down the group, atomic radius or covalent radius increases. And thereafter silicon, from carbon to silicon, there is an increase. From silicon to lead, a small increase can observe. This is due to the presence of comparative field d and f orbitals in heavier members. And if we check with the ionization enthalpy, decreases down the group. If we check with the electronegativity, you can see the electronegativity values here. While moving down the group, electronegativity decreases from carbon to zinc. From carbon to silicon, it is decreasing. For silicon, germanium and tin, it is same. And to the lead, it is increasing. Why it is happening? Because due to small size of the elements in the group. they are more electronegative than group 13 elements, because compared to group 13 elements, group 14 elements are smaller in size. If we check with the melting and boiling point, carbon and silicon having higher melting and boiling point. It is due to their network and covalent bonded structure. We know they have the ability to form 4 bonds with other atom, so their covalent nature will be more compared to other elements. We'll see the chemical properties of group 14 elements. First one is reactivity towards oxygen. Group 14 elements heated with oxygen to form oxides. Two types of oxides, first monoxides and dioxides. For example, dioxide, carbon monoxide, silicon dioxide, such as it will form monoxides and dioxides. And if check their nature, the oxide's nature, as we move down the group, acidic character of the oxide decreases. Acidic characteristics of oxides decreases while moving down the group. Thus, carbon dioxide, silicon dioxide and germanium oxides are acidic, whereas tin oxide, lead oxides are amphoteric. That is, it will show both the properties of acid and base. Carbon monoxide is neutral, germanium monoxide is acidic, while tin oxides and lead oxides are amphoteric. Reactivity towards water. Carbon, silicon and germanium are not affected by water. Only tin reactive towards the water and it forms tin oxide. And their common oxidation state of these elements are +4 and +2. Oxidation state is +4 and +2. The next one is reactivity towards halogens. They reacted with halogens and form halides with formula MX2 and MX4, where MX4 is covalent in nature. Exceptions are tin fluoride and lead fluoride, which are ionic in nature. And stability of dihalide, that is MX2 form, increases down the group. Except CCl4, other tetrachlorides are easily hydrolyzed in water. And we know there are a lot of compounds made up of carbon. Note other elements forming these much compounds. Why carbon is showing these anomalous properties? Why carbon is so special? Why an entire branch of chemistry dedicated to carbon? The reasons are it is having very smaller size and high electronegativity, higher ionization energy and unavailability of d orbitals. And it has the ability to form p-pi multiple bond with itself, with the other atoms. For example, carbon-carbon double bond, carbon-carbon triple bond, carbon-oxygen double bond, etc. The heavier elements in the group 14 do not form such p-pi bond. And it is having a special ability called catenation. That is, carbon atoms have the tendency to link with one another through covalent bond. That is, a carbon atom can link with itself. This ability is known as catenation. The catenation ability decreases down the group like this. Lead does not show catenation property. And the other property is tetravalency. Carbon can form bond with other four elements. Due to property of catenation and pp bond formation, carbon is able to show allotropic forms. We'll see what are allotropes. What are allotropes? Allotropes are the compound which have various physical forms in which element exists are called allotropes. If you check with an element, it can exist in different forms in nature. For example, diamond, graphite, etc. These are the allotropes of carbon. We'll see more allotropes. These are the allotropes of carbon. If you check with graphite and diamond, both are made up of carbon. But look at its images, both are very different. It is very dull, opaque, soft, common. But if you check with diamond, it is transparent, hard, rare, etc. So these both having different physical properties, but these are made up of a same element. We'll see with diamond. Diamond is the one of the best known allotrope of carbon. We are using diamond in both industrial applications and to form jewelries. It is the hardest among the natural mineral. It is used in cutting, drilling, grinding, and for the formation of jewelries. And in this one, it is having this kind of structure. It is three-dimensional network structure. All carbons are formed by covalent bond. Here carbon is sp3 hybridized. Each carbon is sp3 hybridized. Next one is graphite. In the pencils and all we are using graphite. It is a good conductor of heat and electricity. It is the thermodynamically most stable allotrope of carbon. It is the most stable allotrope of carbon. And in this one, carbon is sp2 hybridized, whereas in diamond it is sp3 hybridized, but in graphite carbon is sp2 hybridized. And it is in the form of hexagonal rings, plane of hexagonal rings. It can also used as a lubricant. The next allotrope is fullerene. It is prepared by heating graphite in an electrical arc in the presence of helium and argon. It is like a football-like structure. And various type of fullerenes are there, C60, C70, etc. This is the other allotrope of carbon. These all about the carbon family, and other portions such as important compounds of carbon are deleted. So children, study well. Thank you.